Hey guys, in today's lesson Herbson teaches a different type of story problem. Here's the first one we're going to be going over. Okay. It says the owner of an original copy of a comic book sold it at an auction in the year 2005. The owner bought the book in the year 1980 for $55. The value of the comic book increased at a rate of 3% per year. Now, it doesn't say $3 per year, it says 3% per year. That's very important. How much should our comic book be sold for? So we're finding the dollars. So the unit I'm finding the answer for is the money. So I make a units box just like I previously have, and the two highlighted units are dollars and years. So years is the X, dollars is the Y, just like normal. But then we run into something a little bit different. Dollars per year. Well, the problem is there is no dollars per year. It's not a dollars per year, it's a percent per year. So then you should cross out the dollars and put percent per year. Now, the percent per year is 3%. So put plus 3% because it increases. Now, if it was decrease, I'd put minus 3%. But don't put times X, okay? You can only do that if it's a money amount. Alright, well, here's where we go with this. When your rate of change is a percent, okay, that's called a growth factor when it's a percent. Growth factor. Now, what you need to do with the percent is take 100%, because that's your whole percent, add 3%, and move the decimal, take 103%, and move the decimal twice to the right, so 1.03. Now, make a table just like you would before, but the table is going to work out differently, okay? X is years, and Y is percent. And you're going to go 0 to 1 to 2, just like before. Now, before the 3%, we started at $55. Now, we are not going to add on this problem because it's a dollars and a percent. Instead, what we do is multiply by the growth factor 1.03. Okay, and that will find what the new value is after each year. You need not 0.03, you need to take 100% and add the 3%, or minus the 3% if it's going down. It was added there. So 55 times 1.03. So now it's $56.65 after 1 year. Then times 1.03. $58.35, because it would be 4 round up to 9. Now, what we have here, we don't make the graph with the line, okay? The reason why is because it's not a linear function. It's an exponential function. It's an exponent function, not a linear function. When you're not adding every time, okay, you're multiplying every time, so it's an exponential function. Now, here's how we line up an exponential function. We put a times b to the x power equals y. It's b to the x power. Put the caret symbol there if you want. Now, here's what a and b stand for, okay? I don't even really need to have you write it out. A is where your y started one. You're going to leave the y with it, okay? And also, here's another thing I should have done. Okay, no, never mind. Just keep it like that. Okay, your A, where did your Y start at? 55, that's your A. And then you started multiplying. What did you multiply by all the time? You multiplied by 1.03. And then you're multiplying by it over and over, which is where the X power comes into effect. And that's your equation. That's all you have to write. Now, we need to figure out the answer to the problem. Okay, now you need to come up with a year's amount here. In Algebra 2, off an exponent function in a story problem in Algebra 1, you need to put something down here below. Okay, now you bought it in 1980. Now it's 2005. you need to subtract the years amounts. You need to take 2005 minus 1980 to figure out how many years that is, and that would be 25 years. So 25 goes in the years column, and now we have to figure out what money amount goes with 25 years. So again, you see I'm getting the 25. I'm just subtracting the year increments. So x is 25, so we just put 25 in for x. So 55 times 1.03 to the 25th power equals y. And you're going to just enter that all into your calculator, okay? 55 times 1.03 to the 25th power, and you come up with $115.16. And that's your answer, okay? $115.16. And there you have it. Really, it doesn't take all that long to do, but you need more practice on it, so I'm going to keep on going. Okay, second example. Again, you write a times b to the x power equals y, and then you look in your y column. A is the beginning amount, b is what you're timesing by, and then it's to the x power. You're always going to substitute the number in for x. You don't really substitute the number in for y in an exponent function until Algebra 2. Okay, next example. You put $125 in a savings account that earns 2% interest each year. You make no deposits or withdrawals. How much will the investment be worth in 10 years? So you're finding the money amount. Okay, so you got dollars and years. So the time unit's X, as it always is. That's your independent unit. Then Y is that. Then per. Dollars per year. Okay, now 2% interest. What does interest do to a bank account? It adds to it, okay? If you don't know whether it's add or subtract, you might as well come and ask me, okay? But if you know it, just put it. Plus 2%. Now, when your rate of change is a percent, you need to take 100. It's a growth factor. It's growth, okay? So you take 100% plus 2%. 102%. Move the decimal 2 to the right, and 1.02 is your growth factor. Now I go to my table. So X is years, and Y is dollars. 0, 1, 2. Now the money amount begins at $125. But again, we're not going to add. See, what I do with a money, because you see, taking a dollar amount plus a percent doesn't make any sense. The operation is always to multiply by the growth factor, which is 1.02. And the 1 needs to be there. It can't be 0.02. Okay. Okay, so if it's growing, I'll have $127.50 after 1 year. Then I times by 1.02 again. I'll have $130.05 after year 2. Now block it off, and 10 years, okay? So I don't need to subtract years on this problem like I did on the first one. I know it's 10, okay? So remember, don't make the line. You make the line when you repeatedly add, okay? Because it's not a linear function, it's an exponent function. So, to set up an exponent function, it is always, unless you're told differently, a times b to the x power equals y. Okay, so equals y, and the y starts at $125, so a is 125. And then b is what we're multiplying by, which would be 1.02. Make a caret symbol. And then you put 10 in for x, because we have to find what goes with the 10 in the function. Okay, and you can just find that on your calculator, because really the variable is just on one side by itself. So you just simply punch in 125 times 10 to the 10th power. Whoops, sorry. 125 times 1.02 to the 10th power. Caret 10. and we get $152.37. So that is what we have found. We have found what goes with the 10 in the function, the pairing, and $152.37. Cha-ching. Okay, example 3. In the year 2004, a person purchased a car for $25,000. The value of the car decreased by 14% per year. Calculate the car's value in the year 2012. So I'm finding the car's value in 2012. So you got dollars and years. So years is X, dollars is Y. And per dollars per year. You don't have a dollars per year, it's a percent per year. Okay? And it's decreased, so that would now be minus 14%. Please read the problem. So that is a decay. So to find what the decay is, we take 100%, but instead of adding 14, we subtract 14%, which should be 86%. Now move the decimal twice, and we would have 0.86. Remember to put a 0 as a placeholder. And that is your decay factor. Now again, with these percents, it's an exponent function because it wouldn't be adding over and over on the table, it would be multiplication. Okay. Now we did kind of ones like these earlier in first semester when we took the before times the percent times before equals after, but now that the percent is happening over and over and over again, I use a table. Okay, see, I didn't in the fall because the percent just happened one time. It wasn't like repeated like it is now. So 0, 1, 2. So if you're wondering why you I'm not overcomplicating it. The percent times before equals after isn't going to work. That only works if the percent just happens one time. Here it's not happening one time. It's happening every year. Okay, so start at $25,000. And then we start multiplying by 0.86. Now since I'm multiplying by a less than 1 factor, it's going to decay, it's going to go down. So $21,500. $18,490. Now I block it off, and what's my job? I got to find the car's value in 2012. Don't put 2012 there. That looks idiotic. You need to take 2012 and subtract the initial year to find out what goes there. You're not going to put an actual year, okay? That's not how we set up equations. That's 8. So 8 would be my year's value. So since I'm multiplying, do not make the line graph, okay? Because it's not a linear function. It's an exponent function. Exponent function. So, a times b to the x power equals y. So equals y. So y started at 25,000, but after that we didn't add. We multiplied by 0.86. And it's to the x power. Not times x either, okay, to the x power. Okay, well we have to find the y that goes with the 8, so we just substitute 8 for x. 25,000 multiplied by 0.86 to the 8th power equals y. And these are easy to solve. It gets tough what makes it tough is when they give you the y and you have to go back and find the x, but that doesn't really happen in Algebra 1. Okay, in Algebra 2 it does, but I mean, you guys can get it, but I'd have to teach it. It's a lot more work. $7,480.45. And there's your answer, okay? So we know that that matches up with our 8, and that's your answer. And I don't even really care how it's round personally. I usually go to the cents place, but if you just go to a dollar amount, that's cool too. Okay, last problem. There are 128 teams at the start of a citywide basketball tournament. 50% of the teams are eliminated each round. How many teams are left at the beginning of the 4th round? Teams. Now you could probably do this one without algebra, but I'm going to use it. So teams and rounds. Now the rounds is your time unit, so that's X, and then teams would be Y. So per. Teams per round. Okay, now eliminated means minus, so it'd be minus 50%, which is a decay factor. So now you got to find the actual decay factor. 100% minus 50%, and that's 50%. So move the decimal twice, 0.50. Okay. So use your table to visualize what's happening. So teams is Y, rounds is X. So 0 to 1 to 2. Okay, so we had 128 teams to start with. Then I multiply by the factor 0.50. That's going to take us to 64. 0.50, that takes us to 32. Now, a lot of people will read that problem, they'll put 4, because of the 4 rounds, but they haven't played the 4th round yet. It says beginning of the 4th round, so really, we're just looking for the 3 round. Now, you can do one of two things. You can just multiply by 0.50 again to get the answer, 16, or you can use your A times B to the X power equals Y. So A, okay, would be 128. We're multiplying by 0.50 to the X power equals Y, and then 3 replaces the X. Okay, then we're going to get it. We got 128 times 0.50 to the power of 3, and I get 16. Okay, 16 teams. Now, a couple pointers for you. On your table, just put 600. Just use 600 for your A. Just write the word million after you're done with the problem. Okay? Number 2, you're going to get an insanely high answer. Don't overthink it. Okay? Remember, your years, when you're given a beginning year and ending year, you need to minus those to know what year goes on the table.